Welcome to the product rule. The goal of this video will be to find derivatives using the product rule and also to find the equation of a tangent line. Let's go ahead and get started. We've already found that the derivative of a sum is the sum of the derivatives as stated here. However, the derivatives of a product is not the product of the derivatives. Let's take a look at why it's not the product of the derivatives. We know the derivative of x to the fifth by using the power rule is equal to 5x to the fourth. So if we try to find the product of derivatives, it's easy to see this does not work. For example, instead of finding the derivative of x to the fifth, let's say we found the derivative of x squared times x to the third. So here we have a product. If we take the derivative of each of these and then multiply them, here we'd have 2x and then we'd have 3x squared. Obviously that's equal to 6x cubed, which of course is not equal to 5x to the fourth. So this just doesn't work. We cannot find the derivatives of a product by finding the product of the derivatives. We're going to have to find a different method. So this will not work. And the way we find the derivative of a product is from the product rule. And here's what it says. The derivative of a product is the first factor, f of x, times the derivative of the second factor, so g prime of x, plus the second factor, g of x, times the derivative of the first factor, which would be f prime of x. So we have the first times the derivative of the second plus the second times the derivative of the first. Let's go ahead and apply this to the previous example. Again, we know that the derivative of x to the fifth is 5x to the fourth. So if we break it up into a product and then we apply the product rule, let's see if we get the same thing. So here we have the first function times the derivative of the second. We're going to come back and find that, plus the second times the derivative of the first. I haven't done any calculus yet. I've just written out what we're going to do. So now we're going to find the derivative of x to the third, which of course is 3x squared, plus x to the third times the derivative of x squared, that would be 2x. So simplifying here, we would have 3x to the fourth plus 2x to the fourth, and this does verify we would have 5x to the fourth, which we know to be the derivative. Now of course this isn't a proof. The proof is in the text, but this does verify that this formula does work, at least in this case, and in fact it works for any product. Let's apply it to this function. Now over here I've written the product rule so we can reference it, and I've shortened it a little bit. I've just called the first function f and the second function g, but it's the same formula. So in this problem here, this is our function f and this is our function g. Let's write out what we have to find and then we'll find it. So the derivative is equal to the first function times the derivative of the second plus the second function times the derivative of the first function. I haven't found these derivatives yet. I just wrote out the product rule, and now we will calculate the derivatives. The derivative of 2x squared plus 3x plus 5 would be 4x plus 3 plus the second function times the derivative of 4x minus 3, that would be 4. So this is our derivative function. Now we just have to clean it up, meaning we have to multiply all this out and then combine like terms. So to save time, I multiplied all this out and I've identified the like terms. Now I'm going to combine the like terms to find the final derivative function. And that would be 24x squared plus 12x plus 11. This is a derivative of the initial function. Now you might ask yourself, could you just multiply all of this out and then find the derivative just using the basic power rule? And in fact you could. I'm not going to take time to do it, but I will show it. If you were to take the time to multiply all of this out, there would be 6 different products. You would get this. Then if you combined your like terms, you would have this. And then if you just found the derivative of each term, you can see that this derivative matches the derivative from the previous slide. Of course, it's the same function. So either way works, but we do want to use the product rule in many cases because it is going to be a lot easier in many cases. Let's take a look at another. Here's a problem where it might be a lot of work to multiply all this out. Let's try to find the derivative using the product rule. I'm first going to write out what we're going to do and then we'll do it. Okay, so again, this would be our first function, this would be our second function. Here's our product rule for reference. We have f times the derivative of g plus g times the derivative of f. Our next step will be to find these derivatives and then multiply and simplify. The derivative of x squared plus 3x minus 9 would be 2x plus 3. And the derivative of 3x squared minus x minus 5 would be 6x minus 1. So if we multiply all this out, you can see there's going to be a lot of different products. You might want to pause the video and double check this, but now we have to combine our like terms. So let's first identify them. So this finally simplifies to 9x cubed plus 24x squared minus 50x plus 24. So as you can see, there's a lot of algebra in finding these derivatives, and of course if you miss one sign, it's going to throw everything off and it's going to be very difficult to go back and find your error. So you have to be extremely careful, and if you do so, you'll be rewarded. Let's take a look at one last problem. Given the function f of x, find the equation of the tangent line at x equals negative 2. Now there's a lot going on in this problem. The first thing I want to do is take a look at the graph of this function. So we're going to type the function into y1. Let's go ahead and adjust the window to the following. Negative 3 to positive 3 on the x-axis, and let's go from negative 100 to 100 on the y-axis. Let's hit graph. Okay, so here's our function. The first thing we need to recognize is in order to find a tangent line, we're going to have to find the point on the function, not just where x equals negative 2. An easy way to do that is to hit second graph and type in negative 2 if you have it on the asked feature, or you can scroll around and find the negative 2. So the point of tangent C is going to be negative 2, negative 3. Let's write that down. Our point will be negative 2, negative 3. Now in order to find the equation of a line, we have to find the slope of the tangent line. In order to find the slope of the tangent line, we have to find the derivative of this function. So let's go ahead and do that. We're going to have to use our product rule. There's our first function, there's our second function. Let's write out the product rule and then we'll find the derivative. Okay, so I've applied the product rule. One thing I want you to notice is I remembered that in order to find the derivative of 2 divided by x, we have to rewrite this as 2x to the power of negative 1. So I did that here for f and over here when we find the derivative of f. Let's go ahead and find the derivatives and then simplify. The derivative of x squared minus 3 would be 2x. The derivative of x plus 2x to the negative 1 power would be 1 minus 2x to the power of negative 2. So now we have to multiply this out and simplify. 2x times x would be 2x squared. Now 2x times 2x to the power of negative 1, that would actually be 4. Remember, when you multiply x to the negative 1 times x, you add your exponents. Negative 1 plus 1 would be 0. X to the 0 is 1. Plus x squared minus 2. Minus 2, again, this product, the x is simplified to 1, minus 3, and here we have plus 6x to the power of negative 2. Simplifying this, we would get 3x squared minus 1 plus 6 divided by x squared. Now I've gone a little quickly over some of the algebra just due to the time constraint. You might want to pause the video and take a closer look if you need to. Now to find the slope, we need to evaluate the derivative at x equals negative 2. This would give us 12.5. That would be the slope of the tangent line at x equals negative 2. Let's go ahead and find the equation now. Recall that our point was negative 2, negative 3, and our slope is 12.5. So using point slope form, we would have this, which would simplify to y plus 3 is equal to 12.5 times x plus 2. So distribute here and solve for y, subtracting 3 on both sides. We would obtain the equation of the tangent line. And go ahead and verify that. Here's our tangent line in red, and it does look like it's tangent at x equals negative 2. I'd like to go back to the graphing calculator for a moment. So if we go back to our graph, right above the trace button there's a calc menu. If I hit second trace, option 6 will allow you to find the value of the derivative at a given x value. So if I select option 6 and then type in negative 2 where we want to find the derivative, it will verify our slope of the tangent line to be 12.5 at x equals negative 2. I hope that helps you find derivatives using the product rule. Thank you for watching.